All right, this is the second half of the 3.1 notes. The majority of this we did review in class, or not the majority, but the beginning part of this we did review in class, but we're going to go through some strategies that will help you to identify both the lines and transversals that apply to specific angles, and also how to identify if two angles relate to each other as alternate interior angles, same side interior angles, or corresponding angles. First though, we'll start with just going over some of the true-false questions that we did complete in class. The first here says that a transversal intersects only parallel lines. That would be false. If you go ahead and you look at the example in the book, which is identical to the one on the first page of the notes, you will see that that is an example of two lines that are not parallel and in fact have a transversal. If we go to the second one, skew lines are not coplanar. Again, coplanar is meaning that they are not lying on the same plane. We did also see, if you look back to the definition, that this is actually the definition of skew lines. Skew lines are just like parallel lines in that they do not contain any of the same points. However, they are not on the same plane, so they are not parallel. So this one here would be true. The next states that if two lines are coplanar, then they are parallel. What you can do with this is you can actually take a sheet of paper, and if you use your pencil as a line, you can see that if you have a second line that is on the plane, okay, that it is possible that these would be parallel, but if you were to take your pen and just move it slightly to the right, you would see that these two lines would end up intersecting. They are coplanar, but they are not parallel. We only need one counterexample to show that this is in fact false. If number 4, if two lines are parallel, then exactly one plane contains them. So if we take a look again and take a look at our two parallel lines, assuming that the paper here is our plane, okay, well, if we were to try to move this one to a different plane, we would see that in fact these are no longer parallel, and in fact these become skew lines. Okay. So this example here would have to be true in that if you take a look, there's the only way we can have two parallel lines is if they do lie on the same plane. Again, otherwise we have a different term, skew lines, for two lines that do not contain any of the same points but are not on the same plane. So this one here is true. Right? Now, next, remembering that for something to be a transversal, it needs to intersect at least two lines in 2 points, meaning that if we look at the first example here, we can see that line L, in fact, intersects J and K here and here. So L would be a transversal of J and K, but if we were to look at J, for example, it does intersect L, but does not intersect a second line, and the same would be true for K. So in this particular case, L is the only transversal. Now if we look over to the next example, a good strategy with this is to go ahead and simply look at one of the lines and then see if it intersects the other two lines at 2 points. So if we look at line L here, we can see that it intersects J here and it intersects K there, meaning that L would be a transversal of J and K. So we can list that L is a transversal here. Then if we go ahead and we look onto another line, we can see that J in fact intersects L at this point and K at this point, meaning that it intersects at least two lines at 2 points. So K would also be a transversal. And if you go through and you do the same thing for, I think you might have mixed that up, but the same thing would work for both J and K in this example. If you take a look at any of these lines, they intersect the other two lines in 2 points. Now, moving on to our third example here, if we take a look at our first line, we can see that J does intersect two lines, but it only does so at 1 point. And if you do the same thing for K and L, you'll see that all of them only intersect at one point. Okay, for a transversal, we need it to intersect in at least 2 points. Therefore, this one has no transversals. Moving on to the next section. If you notice, I went ahead and I have some markers, so I went ahead and I saw that there were a lot of angles here and that I would probably get a little bit confused, so I went ahead and color-coded each one of the numbers, and that color code will correspond with those particular angles. And if I need to double up on a color, then that's okay. I can see that, and mostly it's just for when I'm applying that particular problem. So I take a look, and here I have angles 1 and 3. So I'm going to go ahead and put a green mark here at 1 and also at 3. Now, what I'm going to do, and you can use a different sheet of paper if you like, is I notice that if angle 1 deals with line K and line T, and angle 3 deals with line L and line T, and neither one of them have really anything to do with in, so I can be a little less confused. You can use a sheet of paper. I'm using a San Ramon Valley Unified School District Hall Pass, but you certainly don't need to use one of those. And I'm going to actually cover up the part of the problem that makes less sense to me. Now it should become much more clear that we have this line T, which intersects both lines K and L. Oop, there's the bell. Okay, at 2 points. Okay? And we do see that both L and K do not intersect T, so at more than 1 point, or I'm sorry, each other at more than 1 point. So in this particular case, we see that T intersects 2 lines at 2 points, meaning that 1 and 3, for angles 1 and 3, the lines would be K and L, and the transversal is T, the line intersecting K and L at 1, 2 spots. And I will have to continue that later as I have a class coming in now, but you can go to this, or on the same YouTube account, you can go to 3.1 continued, and you will be able to see the rest of the explanation of the note sheet.